Hi everybody, thanks for coming back. In this video we're talking about graphing functions. So let's get really right into it. Let's do a quick review of what functions are. So remember that functions are rules that give us a specific output, which is usually y, when we use a specific input, which is usually x. Sometimes you'll see f of x in place of y. That still means the same thing. So here is an example of a function table. This column right here shows you the function itself, y equals 2x plus 1. So the function is the math that's happening to x to get y. So when we plug in our x's, so we plugged in the x's 1 through 4, and here I've shown you the math that would happen to those x's, you'll get these y's. So if your x is 1, you'll multiply 1 by 2 and then add 1 to get 3 and so on. So that's a quick review of what a function is. We also covered here like figuring out what the function rule is if you're just given a table such as this one right here. All right, in order to figure out what the function rule is, you can go through the 3 different trials. It's sort of a trial and error thing, and you're just going to see what works. So the first thing you're going to do is see if there's anything you add to x to get y. If that doesn't work, you will see if there's anything you can multiply by x to get y. And if neither of those two work, what you'll do is you'll look at the change in y, like how much y increases or decreases. And whatever that number is, you're going to multiply that by x, and then you have to figure out what you should add to that answer to get y. Let's do a few examples. Actually, we can use this one as an example here first. So this table right here, we've got x is 1 and y is 4, x is 2 and y is 5, x is 3 and y is 6, x is 4 and y is 7. So you should first just start and see if there's anything you can just add to x to get y. So, start with 1. So 1 plus 3 would give you 4. So for that to be the function, that would have to be true for all of these pairs. So does 2 plus 3 equal 5? Yes. Does 3 plus 3 equal 6? Yes. Does 4 plus 3 equal 7? Yes. So that has to be our function. It has to be y equals x plus 3. All right, so that's our function right there, y equals x plus 3. That's how this function works. All right, let's do a couple more examples real quick. So here's our table we've got here. So first start and see if there's anything you can add to x to get y. So 1 plus 1 gives us 2. All right, so let's move on. 2 plus 1 is not 4. 2 plus 2 is 4. So right away, since you don't have the same number that you can add to x to get y, addition is not your rule. You're not going to be simply adding to x to get y. So let's try multiplication. So 1 times 2 would give you 2. All right, 2 times 2 does give you 4. 3 times 2 does give you 6. And 4 times 2 does give you 8. So this function has to be y equals 2 times x, or just 2x. All right, let's take a look at this table right here. Let's start with addition. All right, to go from 1 to 1, 1 plus 0 is 1. All right, so is that true here? 2 plus 0 is not 3, it's 2. So we're not going to simply be adding to x. All right, let's try multiplication. 1 times 1 is 1. 2 times 1 is not 3. So we're not simply going to be multiplying to get our y. There's got to be a combination of both multiplying and adding. So what we do first in a case like that is we look at the change in y. So to go from 1 to 3, to go from 3 to 5, to go from 5 to 7, in all of those cases, we are increasing by 2. So it's a positive 2. All right, you're going up by 2. All right, so our function is going to start with y equals 2x. All right, 2 times x. So this number, the number that your y increases by, is what you multiply your x by. But there has to be more. We have to be adding something. We have to be adding something to get to y. So what might help is you might want to draw a third column here and figure out what you get when you multiply x by 2. All right, so what is 1 times 2? It's 2. What is 2 times 2? It's 4. What is 3 times 2? It's 6. What is 4 times 2? It's 8. Now you can figure out what you have to add to this number to get your y. So to go from 2 to 1, you're going down by 1. To go from 4 to 3, you're going down by 1. To go from 6 to 5, you're going down by 1. 8 to 7, going down by 1. So we must be either subtracting a 1 or adding a negative 1. All right? So we can say that our function rule here is y equals 2x plus negative 1, or y equals 2x minus 1. It means the same thing. All right, so that was a little bit of an A side, but let's get into actually graphing a function. All right, so every function table will give you an x and a y, right? Well, those pairs can form an xy coordinate that can be plotted on a graph. All right, so this table right here, if our x is 1 and our y is 4, that's the coordinate 1 and 4. If our x is 2 and our y is 5, that's the coordinate 2 and 5. If our x is 3 and our y is 6, that is the coordinate 3 and 6. If our x is 4 and our y is 7, that's the coordinate 4 and 7. All right? So those can all be graphed on a table, and they will all give us, they'll all give us a straight line. These functions that we've been working with so far are called linear. So that means that they're going to, when you graph them, give you a straight line. So to graph your function, you're just going to simply, if you're just given a function and you're told to graph it, just plug in a number for x and get a y. This will give you an xy pair, and you just need at least 2 xy pairs to graph them. Let's do a few. All right, so here we have 4 different functions that we're going to graph. So in order to graph them, you pick your x, and then you get your y according to the function rule. I always tell my students work with low numbers, because usually the graphs that you're going to be using aren't going to have huge increments on them. So don't pick 30 for x, because this graph certainly does not go up to 30. So if our function here is y equals x plus 2, and I pick 1 for x, 1 plus 2 is 3. So I have the pair 1 and 3. All right, if x is 2, 2 plus 2 is 4. So these are my 2 coordinate pairs that I'm going to point. So 1 and 3, 1, 1, 2, 3, and 2 and 4. All right, so if I graph that, it'll look approximately like that. I know my line's not very straight, but that's okay. All right, let's do the next function. So y equals x minus 1. Again, I'm just going to pick low numbers for my x's. So if I pick 1 for x, 1 minus 1 is 0, so that is 1 pair, 1 point. If I pick 2 for x, 2 minus 1 is 1. All right, so here we have a couple different pairs. So 1 and 0 is right here, 2 and 1 is right here. Okay, so again, so I graph it, I draw a line through it. Your lines will probably be straighter than mine, but that's how it is. All right, let's do the next function. All right, y equals 2x plus 5. So I pick a 1 for x. You don't have to pick 1. You can pick like a negative 1 or a 0 or whatever, but I like working with 1 and 2. So if I pick 1 for x, 2 times 1 is 2, plus 5 is 7. So 1 and 7 is one of my points. If I pick 2 for x, 2 times 2 is 4, plus 5 is 9. All right, so 1 and 7, 1, 1, 2, 3, 4, 5, 6, 7, and 2 and 9. This line is going to have more of a steep slope. Slope is something we're going to talk about in a few more weeks. You can see it goes about like that. Okay. All right, let's do the final function. We'll be done. So if our function is negative 2x plus 3, I pick 1 For x, -2 times 1 is -2, plus 3 is 1. All right, if I pick 2, -2 times 2 is -4, plus 3 is -1. All right, so I plot the points 1 and 1. There's right there. And 2, -1. So that's it right there. If you notice, hopefully, that this graph goes in the opposite direction. And that's because we multiplied our x by a negative number. Okay, so that is my little tutorial on how to graph functions. Join me next time, won't you?